Students, today we will discuss chemical properties. Yes, oxidation state. Fluorine always show -1 oxidation state except in HOF. And other halogens show positive oxidation state also. If a halogen accepts an electron from highly electropositive from Na positive spores, then it show -1 oxidation state. And if sharing an unpaired electron with less electronegative, then also show -1. But if sharing an electron with more electronegative, then show +1 oxidation state. For example, in ClF3, chlorine show +1. Now, oxidizing power. Halogens have strong tendency to accept an electron because they become noble gas. F2 is strong oxidizing agent, so it converts into the fluoride ion, and chlorine only for bromine and iodine, and bromine for only iodine. I2 is weakest oxidizing agent, I negative strongest reducing agent, and F negative then weakest reducing agent. Yes, students, now reaction with water. Fluorine react with water. It dissociate and give oxygen. And chlorine and bromine react with water to form hypohalous acid. But iodine reaction when with water is non-spontaneous. This is the reverse of this reaction. I negative O2 and H positive gives I2. Now anomalous behavior of fluorine. It is small in size, high electronegativity, high ionization enthalpy and absence of d orbital. They form ionic and their ionic and covalent radii, melting point, boiling point are lower than expected. Form only one oxo acid and HF is liquid. Reactivity towards hydrogen. Halogen form halogen acid, or we can say that hydrogen halide. When we move from top to bottom in the hydrogen halide, then the reactivity towards hydrogen decrease. Why? Because the size of halogen is increase. And students, HF is liquid and other halogen acids are gas. Boiling point from HCl to HI increase because van der Waals force of attraction increase. And students, when we move from HF to HI, dipole moment decrease because electronegativity difference decrease. Ionic character decrease, electronegativity difference decrease. Bond length increase due to increase in size, bond strength decrease. Thermal stability decrease due to bond strength decrease. And acidic strength increase because here bond length increase. They easily give H positive, so acidic strength increase. Reducing power increase. These are those due to increase in size of halogen. Yes, students, reactivity towards oxygen. Fluorine form only two oxides, OF2 and O2F2. They are strong fluorinating agent. These are oxygen fluorides because here fluorine is highly electronegative than oxygen. Chlorine, bromine form oxides in their oxidation state positive. Higher stability of oxides of iodine due to greater polarizability. Multiple bond formation between chlorine and oxygen due to presence of d orbital. But bromine lacks both these characteristics. That's why oxides of bromine is least stable. And chlorine form highly reactive oxidizing agent oxides. ClO2 is stable in dimer state because ClO2 has odd unpaired electron. And bromine form least stable oxides. I2O5 is good oxidizing agent. Now reactivity towards metals. When halogen react with metal they form metal halides. But ionic character from metal fluoride to metal iodide decrease because size of halogen increase. And reactivity towards other halogens. When halogen react with other halogen they form interhalogen compounds where the formula is XX dash N and X is large in size halogen and small electronegativity, and X dash is small in size and high electronegativity. Now preparation of chlorine. Yes, when magnesium dioxide react with HCl it form chlorine. In place of HCl we use sodium chloride and concentrated sulfuric acid. Then they also form chlorides. And when HCl is treated with potassium permanganate they form chlorides. Now, manufacture of chlorine by Dickens process, when oxidation of HCl in the presence of atmospheric oxygen and in presence of catalyst, it forms chlorine. And in electrolytic process, when we do electrolysis of brine solution, it means NaCl solution, at anode chlorine gas is liberated. Yes, now properties: greenish yellow gas, chlorine gas, pungent and suffocating odor. It react with metal and non-metal. Here aluminium, sodium, iron is metal. Chlorine forms chlorides, and with non-metals it also form chlorides. And it has great affinity for reaction with hydrogen and react with compounds. Those contain hydrogen. Form hydrochloric acid. In the reaction with hydrogen, form hydrochloric acid, and H2S is compound of containing hydrogen, form HCl, and C10H16 is also a compound containing hydrogen, form HCl. When sodium hydroxide, cold and dilute, react with chlorine, they form sodium hypochlorite and chloride of sodium. And when hot and concentrated NaO is treated with chlorine, then they also form chlorides, but this is different product, sodium chlorate. And when dry slaked lime react with chlorine, it form bleaching powder. Here is substitution reaction and addition reaction. Substitution reaction, hydrogen replaced by chlorine here, and addition reaction, in C2H4 chlorine is added. Chlorine water when standing, then it loses its yellow color. Why? Due to the formation of HCl and HOCl. Yes students, chlorine has oxidizing power, so it oxidizes ferrous to ferric, sulfides to sulfates, and sulfur dioxide to sulfur trioxides. And iodine, when react with chlorine, it form iodic acid. Yes students, chlorine is powerful bleaching agent. Chlorine react with water to give HCl and O. Here O is nascent oxygen. It acts as bleaching agent. It convert colored substances into colors. Yes, uses preparation of poisonous gas. In the manufacturing of poisonous gas is phosgene, formula is COCl2. Preparation of tear gas, preparation of mustard gas also.